Hello there, this is an Algebra 1 video. This is Chapter 8, Section 6, and today we're going to be applying what we've learned about the zero product property to solving quadratics of the form x squared plus bx plus c equals 0. And I gotta tell you that before we get started, the method in which I'm going to be using in this video is not in the textbook because this method's cooler. So, I need you guys to understand this diagram. It does not need to be this large in the future when you do it on your paper. I just wanted to make sure that I could write all the things that I needed to write in there. And it will make more sense once you get doing more problems. But for now, just so that you have it in your paper and your homework somewhere for you to use later, you basically create a plus, kind of splits the page into 4 quadrants, if you will. On the left side, on the left 2 quadrants, top and bottom, you want to place the factors of the coefficient of x squared. So you don't put the actual variable, you just put the coefficients of x squared. And so in this lesson, because they're all going to be of the form 1x squared, you're always going to have a 1 and a 1 for this section. I can tell you right now that in the next section, you're going to be using different numbers here as well, but we're going to get you started with the basics. So for this lesson, these 2 spots should always be a 1. They're the factors of the coefficient of x squared. Also, if you really wanted to, you could even put an x and an x, 1x and 1x on that side. Okay? On the right-hand side, on the top and the bottom, you're going to place the factors of the constant term, which is the c value here. Okay? So the constant term is going to go there. And then you're going to take the diagonals, which is the part that's in red here, and you're going to multiply along the diagonal. So you're going to go x times something and x times something. And once you get those 2 products, you're going to add them together. And when you do that, they're supposed to equal b, which is the middle term right here. And then once you can get that diagram to be working for you and all the numbers match up, then you can write your answer, and your answer is going to go from left to right. And the top is going to be one part of your answer, and the bottom is going to be the second part of your answer. And again, I'm positive that probably sounds really scary to you right now, confusing perhaps, but we're going to do this example right here so you can see how this works. So the first thing is, again, you don't have to make it so big. I'm just going to make a small little plus sign right there. I know that I'm going to have x and x. So basically, when I multiply x times x, I should get x squared. Now I'm going to go to the right-hand side, and I need to put numbers that are factors of 12. Okay, so factors of the constant term, so the c term. Okay, and that's going to be, in this case, I have some options there. I can pick 1 times 12 are factors of 12. I could pick 3 and 4 are factors of 12, and 6 and 2 are factors of 12. And the whole process here is which ones are going to work. I'm going to go ahead and pick one that doesn't work, so you can kind of see how that would happen. Let's suppose that I pick 6 and 2, for example. Then according to the diagram over here, I would multiply along the diagonal, and x times 2 is 2x, and 6 times x is 6x. I would then add, because it says the sum, I would add those 2 diagonals together, and I would get 8x. But 8x is not the middle term. I'm supposed to get a 7x. So that indicates that this is not the right number sequence to choose. So I'm going to go ahead and erase that now. And let's actually go with the right number sequence. And so then I try 3 and 4, for example. When I try 3 and 4, this time when I multiply the diagonal, I get 4x and 3x. And 4x and 3x is in fact 7x, which is what it's supposed to be according to the original problem. So that's what I mean by saying once you have all the right numbers in your diagram and everything works the way it's supposed to, then the answers are going to be the top part and the bottom part. So you're going to go x plus 3, because that's a positive 3, multiplied by x plus 4, because it's a positive 4. If it had been a negative 4, for example, then you would have put x minus 4. So this is now my solution, if you will. And you can check it by doing FOIL if you want. The first time around, you're probably going to want to check it, but once you get really used to it, you'll realize that you won't need to keep checking it anymore. But I'm going to go ahead and check it real quick here. X times x, first times first, is going to give me the x squared. Outside times outside is going to give me 4x. Inside times inside is going to give me 3x, and those are like terms, which will add up to 7x. And then last times last is plus 12. So it in fact works. The other portion of this is that it actually says to solve. So you have to solve for x, and now we have a factored here form. And so we said earlier that when you have a 0 on the equal sign, on the other side of the equal sign, that you can separate these two into individual problems. So either x plus 3 equals 0 or x plus 4 equals 0. So in the first case, you subtract 3, and so your answer is x equals negative 3. And over here you subtract 4, so x equals negative 4. And those are your two solutions. X equals negative 3 and x equals negative 4. So that's basically how you do this. So we're going to just keep doing a few of these. Sorry for that bell there. Because we want to make sure that you get the hang of it. So here we go with the next one. X squared plus 9x plus 20. So we're going to go ahead and do our little plus sign. You're going to have an x and an x because that's how we're going to start with the first coefficient there. And then we have 20. And so for 20, you could pick 5 and 4, 10 and 2, 1 and 20. But because we wanted to add up to 9, I'm pretty confident that 5 and 4 are going to work. And to test it, I'm going to do diagonal 1 is 4x, diagonal 2 is 5x, and that does in fact equal 9x, which is what it's supposed to equal. So now my answer is going to be the top portion, which is x plus 5, and then the bottom portion, which is x plus 4. And in this case, it doesn't actually say to solve, it just says to factor. So we are going to give that as our answer. X plus 5 times x plus 4. Yummy. So now we're going to have you factor these. Remember, at this point, you don't need to solve it yet. It doesn't say equal to 0. They just want you to factor. Make sure that in part B, you write that in the right order because it's out of order right now. So if you try doing it the way it is right now, you're going to get the wrong answer. Make sure that you put it in the right order before you get started. And then we're going to move on to this little guy. So when it says to confirm your answer using a graphing calculator, I'm going to talk you through that. I'm not actually going to throw up the calculator screen up here because it's going to not be very visible. But it's not very hard to confirm using the graphing calculator. So we're going to factor this guy. Again, we're going to have x and x because x times x is x squared. And then for the case of the 12, in this case, I'm not going to do 3 and 4 because 3 and 4 is not going to give me the 8 that I'm looking for. I'm hoping that the 6 and the 2 might work better. But when I multiply along the diagonal, this will give me 2x and this will give me 6x. And that'll give me a positive 8x. But as you can see, the middle term is a negative 8x. So that's close, but still not what we want. So what we're going to do is make them both negative because negative 6 times negative 2 will also give me a positive 12. So don't rule out the option of having negatives in there. And then that time when I get x times negative 2 is negative 2x, x times negative 6 is negative 6x, and 2 negatives make a bigger negative, that's negative 8x, and now everything works the way it's supposed to. So my answer is going to be x minus 6 for the factored form and x minus 2. So as far as how to confirm your answer using the graphing calculator, what you want to do is go to your graph mode, and in your y1, you want to type in the x squared minus 8x plus 12. And in the y2, you want to type in the answer we just got, which is parentheses x minus 6 and parentheses x minus 2. And when you graph that, you should get the same exact graph both times. So instead of seeing like a graph and then a graph, it should not look that way. You should get a graph and then the other graph is the exact same graph, and you should only see one graph there. If that happens, then you can be assured that you have factored it correctly. All right, so we're going to let you try this little guy. And then we're going to go to example 3, where we're doing some more factoring here. So here we go again. I hope you're starting to get the hang of it. X times x. Factors of 15 are probably going to be 5 and 3. And as far as I know that one of those numbers has to be negative because this is a negative 15. So 5 times 3 is positive 15. So it's a matter of which one do we want to be negative. I want there to be a positive 2 here. So if you want this to be a positive 2 when you add them, then that means that the bigger number has to be positive. So the 5 is the bigger number, so I'm going to leave that positive and make this a negative 3. So x times negative 3 is negative 3x, and x times 5 is positive 5x. And you see what I mean by positive 5 minus 3 is going to give you a positive 2x, which is what you want. That's a positive 2x there. And so that's my diagram for me. It's all organized, and so on the top, my answer is going to be x plus 5. And on the bottom, we're going to get x minus 3. So that's factored there. And then over here, we're going to do the exact same thing. We're going to get x and x. For the 18, we're going to go with 9 and 2. Again, you could do 6 and 3, but the 6 and 3 is not going to give you the negative 7 that you're looking for. So I'm going to go with the 9 and 2 because I know that 9 minus 2 is 7. But I don't want 9 minus 2 because 9 minus 2 is going to give me a positive 7. I want negative 9 and positive 2 so I can get a negative 7. So we're going to go 2 times x is 2x. Negative 9 times x is negative 9x. And when I add those together, 2 minus 9 is actually negative 7x. And then that's exactly what we want it to be, so that checks. So my final answer will be x minus 9 and x plus 2. So now you can try these on your own. And then we're going to go to example 4, which is where we're actually now into the solving process. So to solve, we're going to first and foremost, like I said before, you have to make sure that it equals 0, and it doesn't equal 0 right now. So we're going to go x squared plus 6x, and we're going to move the 27 to the other side, and now equals 0. Now that it's in that right form, we're going to go ahead and do our little plus thing here. And if you'll excuse me real quick, I'm just going to close my door. So we're going to put on the left-hand side x and x again. And this time we're going to put the factors of 27. 9 times 3 is 27. But we want a negative 27. And we want a positive 6. So we're going to put the 3 negative so that 9 minus 3 will give me the 6. And the 9 times negative 3 will give me the negative 27. So negative 3x on the first diagonal, positive 9x on the second diagonal. And sure enough, negative 3x plus 9x is a positive 6x. That's what we're supposed to have. So everything works out okay. And our final answer was going to be x plus 9. Is the first factor, and then x minus 3 is the second factor. And by the way, it doesn't matter which order you do that in. You could have put a negative 3 up here and a positive 9 down there, and it still would have worked. It doesn't matter what order these are in. It could be x minus 3, x plus 9. And it's equal to 0, so as I did before, to solve, you take each factor separately. So we're going to say x plus 9 equals 0, or x minus 3 equals 0. So here we're going to get x equals negative 9 because you subtract 9 from both sides. And over here we're going to get a positive 3 because you add 3 to both sides. So to check our solutions, because we get 3 and negative 9, and you can check that into the original equation. 3 squared is 9. And 6 times 3 is 18. And 9 plus 18 is in fact 27, so that checks. Then you can try the negative 9. So negative 9 squared is positive 81. And 6 times negative 9 is going to give you negative 54. And 81 minus 54 is going to give you 27 as well. And so they both work, and so we've checked our solutions. So now we're going to let you do these 2 examples. Remember to move the 70 over to the other side before you get going, because it's got to be equal to 0 before you try to factor that. And so here we have our last example, example 5. It says Ling is designing a poster, so this is my make-believe poster here. The top of the poster is 4 inches long, so here's the top of the poster at 4 inches long. And then the rest of the poster is 2 inches longer than the width. So I'm going to claim this is my width, and so the length is going to be 2 inches longer than that, so it's going to be W plus 2. If the poster requires 616 square inches of poster board, find the width W of the poster. So that's going to be, we're going to go W times W plus 2. And then, actually it's going to be W plus 6. Let me adjust that real quick. Oops. Let's take that off there too. If you're wondering why I'm saying that, it's because this is W plus 2, but you also have to add an additional 4 inches. So the 4 and the 2 is going to be 6. So we're going to want W plus 6 here. And it's going to equal 616 square feet, or sorry, square inches. So W times W plus 6 equals 616, and then we're going to basically try to solve this. Now, you might be thinking to yourself that it's already factored, but it's not, because you have to have it equal to 0 in order for this to work. So you can't say W equals 616. This has to be a 0 over here, and it's not right now. So we're going to go W squared, W times W is W squared, plus 6W, and then we're going to move the 616 to the other side, like that. And so now, we're going to have to find our factors, and because these are bigger numbers, it's going to be a little bit more difficult. So we're going to put W and W, and we need to know what goes into 616. Let's see. 4 and 154 work, but again, you're not going to get a 6 out of a 154 and a 4. So let's try a bigger number. 616 divided by perhaps 28. Now we're talking. So apparently 28 times 22 is 616, and if I need a negative 616, but if I go negative 22, then 28 minus 22 is in fact 6. So here we go, negative 22W, positive 28W, and then negative 22W plus 28W is actually 6W, which is what you wanted. And so our answer, or our factored form, is going to be W plus 28. And our other factor is going to be W minus 22 equal to 0. So when you solve this little guy, you're going to get W plus 28 equals 0, and W minus 22 equals 0. So in this case, W equals negative 28, and in this case, W equals 22. But remember, W is the width. So it doesn't make sense for us to have a negative 28, because that would be a negative inches. So that's kind of a throwaway answer. But our actual answer is going to be W equals 22, because that makes more sense for this problem. Remember, you don't want to have any negative widths. So 22 inches. So now we're going to let you do this example here. And once you have completed this do-it-yourself question, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.